Hello everyone. So welcome back and we will do another exercise on system Verilog constraint. So in this particular question, we have to write a constraint of 16-bit vector to generate patterns like or. So we have to generate a pattern in which 0 and 1 is getting repeated two times. So if it starts with 0, then the next bit in the vector should also be 0. If it starts with 1, then the next bit in the vector should also be 1. So pattern should be something like this. So contiguous sets of zeros and ones. So it could start with two zeros or two ones. So our constraint should be capable of generating both these starts. And then everything is similar. There are two repetitions of 1, then two repetitions of 0. Similarly here also, two repetitions of 0, two repetitions of 1. So let us begin. So I will uh, write a rent bit variable that should be of 16 bits, and let us name it A. Now I will begin with the constraint. Let's call it pattern C. Then we will iterate through every of the bits present in A. And here we will try to compare uh, the any iteration variable with its future, with its neighbor, with its upcoming neighbor. So for that reason, we will write if condition in which it will only iterate from 0 to 14. So the reason of writing that is that after it reaches the 16th bit or the 15th bit, if the iteration variable I reaches the 15th bit, and then it will compare itself with the next upcoming bit, but there is no bit after the 15th bit. So for that reason the constraint will fail and we will get an error. For that reason we are limiting it to 14, because 14 is going to be the last bit which can get itself compared to its neighboring bit or the upcoming bit. So after this condition, I will begin with my main constraint. So for that, first we have to look in the pattern, and the pattern is uh, predictable. So here you could see that if you will look at each of the even bit like this and this, each even bit is equal to its upcoming neighboring bit. See, in this case, the zeroth bit, which is 0, it is equal to to the first bit. Here also, the even bit, bit number 2, it is equal to the third bit, which is the upcoming neighboring bit. Here also, the fourth bit is equals to the fifth bit. And if you take a look at this pattern also, you will find the same thing, that the even bit here, the bit number 0 is 1, and the neighboring bit is also 1. and the even bit, the bit number 2 here is 0, and the neighboring bit is also 0. Meanwhile, if you take a look at the odd bit, it is not equal to its upcoming bit. For example, here the bit number 1, which is odd, and it is 0, and it is not equal to bit number 2. Here also the bit number 3, which is 1, it is not equals to its upcoming neighboring bit. So this simply gives us a constraint condition in which the even bit is equal to its future neighboring upcoming bit or the next bit. Meanwhile, the odd bit is not equal to its upcoming bit. So we will simply translate whatever I just said in English into a if else condition. So if that iteration variable I is even, so if that is even, then that particular bit inside the array should be equals to the future bit or the next bit. Else, else if it is odd, then it will not be equal to its bit to the upcoming bit at the right side. So that concludes our system Verilog constraint for this particular pattern. So let us go ahead and try to run this particular constraint multiple times. We will randomize this class multiple times to see whether we are getting occurrences of this pattern or not. But before that, I will write a post randomize function to display the values in binary. After this, let's begin with the one main module. Let's declare a handle for the class. Let's assign an object to that handle. And let us randomize this particular constraint or this particular class for at least 6 times. So I will save the code and I will compile it to check whether I have made any typos. Okay, we do run into some errors and it is at line number 10. Okay, here, since we are writing a constant, we should use 2 equals to, and I think rest should be fine. Yeah, it is fine right now. So let's start the simulation. So what is happening right here? Okay, so we are getting the pattern, but each time the pattern is not starting with 1. Maybe we could try running more occurrences, more repetitions, then we can get the particular pattern. But still, we are getting the correct intended pattern that we want. So let's try increasing the repetitions and let us see whether we get uh, this particular pattern which starts with 1 1 or not. Let's increase 20. Okay, so as you can observe right here, the transcript, that after repeating the patterns or the repetitions of uh, or the number of times our class will get randomized, we did get the other pattern, and our constant is working as per our expectations. So you can see that each even uh, even bit is equal to its neighboring bit, the next bit, and the odd bit not equal to its next bit. So that concludes our another system Verilog constant exercise. I hope you find this video useful and stay tuned for more. Thank you so much.